This grand finale, as NASA calls it, was dreamed up when Cassini's fuel tank started to get close to running empty after 13 years exploring the planet. Cassini was directed into the previously unexplored gap between Saturn's cloud tops and the rings. If you want to see Saturn's beauty, there is no better way to do it than through the eyes of Cassini in its grand finale. The first probe to reach Saturn was the Pioneer 11 probe in 1979. It was at this time that scientists confirmed that Saturn's largest moon, Titan, had an atmosphere. Getting a spacecraft to Saturn is no mean feat, as the whole trip was combating the gravity of the Sun trying to pull Cassini back to the inner solar system. So to help achieve the speed needed to reach Saturn, Cassini used planets as gravitational assists. It flew by Venus twice before returning back to Earth. Earth's gravity then slingshotted it towards Jupiter, which gave it the final push needed to reach Saturn. This alignment of planets, which allowed these gravity assists, only occurs once every 600 years, so timing in this case was crucial. And Cassini really scrapped past Earth on the second time around too. It was only 1,100 kilometers above Earth's surface at its closest approach. This is made even more interesting when you realize what actually powered Cassini. It was powered by 3 RTGs, or radioisotope thermoelectric generators. Basically, the power source came from about 33 kilograms of radioactive plutonium. It's this radioactive decay which gave Cassini power, and even until the end of its life, it still produced about 700 watts. The issue with the spacecraft carrying this radioactive substance was that if the scientists had gotten their calculations wrong and had crash-landed on Earth, everybody on the planet would have been exposed to the radiation. Now, 33 kgs spread out over the whole Earth is a very small amount, but in the worst-case scenario, NASA estimated it would have caused about 5,000 deaths from cancer. They put this down as an acceptable risk, though, as the chances of this happening were only 1 in a million. Cassini used RTGs because solar panel technology wasn't good enough at the time for the Sun to power something so distant. With RTGs, Cassini would have a very long operational life, and it might still be able to carry on, even if it wasn't for the fact it eventually ran out of propellant fuel. Cassini had numerous objectives: to understand the structure and dynamic behavior of Saturn's rings, explore Saturn's moons more fully, measure the magnetosphere of Saturn, study Saturn's atmosphere, and study Titan more extensively. When it comes to Saturn, it's hard to summarize just how lucky we were to have the Cassini-Huygens mission. 4 robotic probes have visited Saturn, but of those, Cassini-Huygens has hands down been the most impactful. And I mean that both literally and scientifically. Its data has provided the bedrock for over 4,000 research papers. It discovered 6 new moons and helped us better understand their composition. It survived 20 years, traveling 7 billion kilometers, and spent 13 of those years around Saturn itself, gathering data on Saturn's gravity, magnetosphere, its rings, and its structure. And Cassini kept gathering data right up until the last moments of its life, as it plunged into the mustard clouds of Saturn's atmosphere and ultimately broke into thousands of pieces. Couple that with the fact that it provided some of the most jaw-dropping, awe-inspiring images of Saturn and the solar system to date, and you have one hell of a mission. They knew they had to go back and visit the moon, but this time with a lander. Now, Voyager 1 and 2 were already en route to Saturn at that point, and so naturally it was too late to include a lander with those missions. Thus, Cassini-Huygens was born, and in October 1997, it was launched into space. The scientists thought they could be landing on an ocean or lake, and so had designed Huygens accordingly. From what you see, though, it actually landed on what could be the bed of a dried-up lake. The mission for Cassini itself has been remarkably successful. As well as scientific data it has picked up over the course of those last 13 years, it has been able to provide some of the most stunning pictures found of space. I just want to showcase some of my favorites of Saturn. And of course, Saturn's moons are beautiful in their own right too. And some very dedicated souls have even taken 1 million photos Cassini has taken to show us what it would be like to be sitting on the Cassini spacecraft. These are all real images. They've only been color-corrected and enhanced and put in order to show movement. There's no CGI, it's simply amazing. As Cassini's fuel began to run low, scientists began to consider how best to get the most data they could out of the time they had left. To achieve this, they sent commands to Cassini, telling it to perform some very close flybys of the planet and some of its moons, getting closer to Saturn and its rings than it ever had before. Beginning on November 30th, 2016, Cassini repeatedly climbed high above Saturn's North Pole, then plunged to a point just outside the narrow F-ring, which is the edge of the main rings, completing 20 orbits in total. Then, on April 22nd, 2017, Cassini would leap over the rings to begin its final series of daring dives between the planet and the inner edge of the rings. This was the Cassini Grand Finale, a series of loops and dives that brought the probe closer and closer to its object of study, facing greater and greater danger as it flew until finally, as its data became purest, as Cassini would fly into the embrace of Saturn itself, Cassini's chance for annihilation would become certain. NASA's website states the reason for this final mission. As it plunges past Saturn during the grand finale, Cassini will collect some incredibly rich and valuable information that the mission's original planners might never have imagined. The spacecraft will make detailed maps of Saturn's gravity and magnetic fields, revealing how the planet is arranged on the inside and possibly helping to solve the irksome mystery of just how fast the interior is rotating. It will vastly improve our knowledge of how much material is in the rings, bringing us closer to understanding their origins. Cassini's particle detectors will sample icy ring particles being funneled into the atmosphere by Saturn's magnetic field. And its cameras will take amazing ultra-close images of Saturn's rings and clouds. No other mission has ever explored this unique region so close to the planet. What we learn from these activities will help to improve our understanding of how giant planets and families of planets everywhere form and evolve. Friends, what do you think about this? Write your views in the comments section and subscribe to our channel to get interesting videos.